apologies for the odd camera angle. So we have to unscrew these 4 screws. Underneath there are other 3 screws that we have to remove. We flip the base and we have to remove all the screws that go around the base. After we removed all the screws, we have to push it from the front to the back, because it has these 2 notches. So this is the power brick, the power supply. Remove the cable that goes from power supply to the main board of the wheel. And then we unscrew all the screws that are holding the power supply to the base. can also unscrew the bracket that holds the power supply cable, just to be easier to work on it, to not get in the way. So if we open the power supply, inside we can find a small board that controls when the power is coming to the wheel. So basically what it does, it will control when you have the power supply plugged in and the USB also plugged in your PC. Only then it will provide the power, and the wheel will start to calibrate. So taking it out, you can see it has a triac in the back that controls that, and usually that's what goes bad. To test that, you can see that the path is blown. So to test that, you can just go straight directly bypassing the track, which I did, but that didn't went very well. So my path just blew again. So that meant there is something with the power supply, I guess, or maybe the board, but yeah. So what we do now is we can just remove that USB functionality, the one that signals to give the power to the wheel, and we'll just provide the power directly. The cons of that is that you'll have to power the wheel first and then plug in your USB. So this is the cable. You see two thick wires, red and black, which are for the power, and then the two thin ones, which are for the USB. So we'll just isolate those small wires. We are not using them anymore. Be sure to isolate them one by one so they will not contact between each other and with anything else in your wheel. We'll clean the wires to prepare them for soldering. So I got a power supply out of a laptop, which I'll be using with that. It has 20 volts and 4.5 amperes max, so 90 watts. The original power supply actually has 24 volts, I believe, but 20 volts will also work. No issue there. So the power supply shows a scheme on the back, which shows where is the positive, negative, and for this particular one, the center is for signal. So we need the negative and positive. So if you don't have electrical scheme on the back of your supply, or you don't know 100% which wire is your negative and which one is your positive. You can test that with a tester. Just set it up on electric potential DC and measure it once with the end of your tester on one wire, the black on the other wire, and vice versa. In my case, you can see here when I put the black end outside and the red one inside, you can see we have 20 volts. And then when I switch for the red one outside and black end inside, we have minus 20 volts. That means that the positive is inside and negative is outside. Okay, so in this case I will not cut the wire because I got a laptop socket that will go with this power supply. That will make it modular, so I will be able to remove the power supply from the wheel. If you do not want to do that and you want just to cut the wire and solder it directly, then you will have to check where is your positive and negative end. If we plug that power supply in this socket, we can all test it once again to see where those contacts are coming from. So basically we saw that we have negative on the outside and positive on the inside. You can use such a tool as helping hands to get the soldering easier. We got our negative soldered. For the positive, what we'll do, we'll introduce a fuse in this circuit, so just in case if everything goes bad, that fuse will blow. So you can see the fuse box here. I went with this one because it seems to have like a really nice cap that you can remove the fuse very easily. So we take a 3 amps fuse to use with that. Put it in, screw the cap back in, and we are ready to test our wheel. This is the first time I'm plugging in this wheel, so I'm not sure what the results will be. Okay, it's moving. So it seems to be calibrating. Nice. Now we make 2 holes in the base casing. One will be for the fuse box and another one will be for the power supply socket. The fuse box has a really nice mechanism that will hold it in place. For the power socket we just use hot glue. So this is how it looks. Really nice and clean, at least on the outside. Here we have 2 wheels. The right one is the one with an original power supply. The one on the left is with the laptop power supply. So they both calibrated. The left one seems to be a little bit slower. So you can see that all the buttons are working, everything is working in that little tool that Windows is providing. So we'll try to testing in a game. Open the race injection here. Looks like it has a nice power to it. Yeah, the force feedback is working pretty well. Actually, for some reason, I feel that force feedback feels better on this wheel than on the other one I have with the original power supply. So in the end, what I got is a working wheel which will use a power supply from a laptop. The power supply will stay outside, which makes everything inside the wheelbase cooler,